All right, good morning. Welcome back to Calc 2. We are going to talk more about partial derivatives and finding minimums and maximums. This is just another 3 problems that I found that seem to be appropriate for your level. One of them a little bit harder, but for the most part, pretty much in line with what your book has already done to you. So let's go ahead and share the screen and we'll just get through with these problems, okay? So I'm not saying you're going to find these explicitly as a homework problem, but they're not too far off. Okay, so let's see here. We have a negative x cubed, all right, plus 4xy minus 2x squared plus 1. All right, so what's our usual steps here, right? The usual step is we're going to find fx and fy. We're going to find all our partials or second partials. So we're going to find xx, xy, and fyy, and technically fyx, but since these two are the same, we're not going to worry about it. Okay. We are going to set, right, fx equal to 0, fy equal to 0. We're going to get a system of equations, all right, and then we're going to solve this system. Solve the resulting system. Okay, and I realize this is easier said than done. In all of the curriculum that C&M teaches, we don't really spend a lot of time solving nonlinear equations. Okay, so it's not the engineering students have anything on you for this. They do have a little bit extra because they took the pre-calc class and they do some of that there. But nobody's. This is always a difficult spot. Okay, we're going to compute, right, the d value here. This is fxx fyy minus fxy squared. Okay, and now we're going to consult the table. Okay, for is it min, max, saddle, or boom? We don't know. Okay, so that's pretty much your steps. All right, so calculate fx, calculate fy, then calculate all the second derivatives. Okay, set our first step, right, our fx fy equal to 0. Okay, you're going to get a system, solve that. You're going to get some points, right? We're going to have a list. Okay, then we're going to calculate the determinant here. If you have points you can plug in, then go ahead and do that. Okay, because sometimes you might get some kind of weird thing like that, where you've got both a min and a max. Okay, the way you're going to be able to tell is at those points, what is our determinant? Okay, and then come back to the determinant. We need to know what fxx is. Okay, and then we're going to consult the table and figure out what's going on here. All right, so that's your procedure. All right, so let's just get started with this. Let me erase this because we don't really need that. All right, so let's go. Fx, that is equal to, right, negative 3x squared plus 4y minus 4x, and then the 1 had a 0 to it. Okay, the derivative of 1 is 0. Fy, okay, well, that's 0. That's going to be 4x. These are all zeros. Did I write this down right? Yeah, I think I did. All right, we're all good. 4x. All right. Now, let's go ahead and take a look at what's going on with fxx. By the way, if it seems that, wow, these always seem kind of to work out, there's a reason. Okay, these can get very, very complicated very quickly. So if we want to keep these something where you can do them by hand and we don't have to worry too much. Okay, fy, what's the partial with respect to y here? Oh, it's a 0. And we have fxy, that's going to be 4. Right? That's also equal to yx. So all we're doing is taking this derivative with respect to y now, okay? Or we're taking this derivative, taking this derivative with respect to x, so we just get 4. Or we're taking this derivative with respect to y, so we just get 4. Okay, so that's step 2. Okay, step 3. Okay, we're going to set fx, which is equal to 3x squared plus 4y, okay, minus 4x equal to 0. Right? We're also going to know that from fy, right, we know that 4x equals 0. So let's go ahead, that's a solution, right? X equals 0, that's an answer. 0 is a number, let's plug that in. So what happens to my fx? We get 4y equals 0. So that means y is equal to 0, right? So remember, all the x's were 0, so we're good, right? So our point in question, 0, 0, right? That's the question. That's the one point that solved both of these equations here. Made them both true at the same time. That's what we want. Okay. Now we're going to go ahead and compute our determinant. So that's step 4. So we have fxx times fxy minus fxy squared at the point 0, 0. Okay. So if I'm going to look at fxx, right, that's minus 6x. And then fyy, right, that's going to be equal to 0 minus, and then fxy, that was 4 squared. Okay, I don't really care what x is because 0 times that is going to be 0. If I did care, I would plug this point into this value here. Okay, so it's like, why are you putting 0 in for x? Because that's what I found out. That's what it told me to do. It said, well, x is 0, plugging it in. So we end up with negative 16. Right? So what happens now? We consult our point. Okay, so when the determinant is less than 0, again, you guys are going to have like a table like this. Okay, so we're going to have d is greater than 0, d less than 0, d is equal to 0. So if d is greater than 0, we got to check. We have to say, well, what's fx doing? If fxx is positive, then we have a minimum here, right? Yeah, we have a relative min. If fxx was negative, then we have a relative max. If our determinant was less than 0, then we have saddle point. And then d is equal to 0. I'm unlikely to give you one of these on an exam or on a quiz simply because it's the end of the story. Like you have no recourse to do anything else. You got to figure something else out. So we have test fails. Okay, so we have no conclusion here. It doesn't mean that there is or isn't a relative max. It just means, well, we don't know. Okay. So you're going to have this as a table. Okay, so if you're looking at your table thinking, what am I going to do? Like you're going to have it. So all we have to do, the determinant is less than 0. That means we have a saddle point. So our conclusion is saddle point. And the point in question would be 0, 0. So saddle point at 0, 0. All right. So that's what we're doing. Okay. Let's try another one. Okay. And that, by the way, that's it. That's as far as you get to go. Okay, we're done at this point. All right, let's try the next one. So this is the square root. So this is f of xy is equal to x squared plus y squared 1/2. Right? Let's get rid of this because I don't want it to be a negative 1/2. We want it to be a positive 1/2. So let's go ahead and change this a little bit. So squared 1/2. All right. So fx, right? This is our first step, is we find our first partial derivative. So that's 1/2 x squared plus y squared to the negative 1/2 times the chain rule, okay, which is going to be 2x here. Fy, that's going to be x squared plus y squared to the negative 1/2. Put a 1/2 down in the front. This 1/2 comes down in front, negative, times the chain rule. Okay, and now we got to solve this. Well, we don't have to solve it just yet, but one moment. Fxx, right? Easier said than done. Let's make some space so we can simplify the function above it here. So the 2's cancel. So we have x times x squared plus y squared to the negative 1/2. All right. So like I said, some of these can be a little involved. So what do we have here? We have a product rule. Okay. Actually, technically we have a quotient rule, but I'm going to use product rule because we're going to keep this negative up here. Okay, so we have a product rule. So what's the derivative of the first, right, times the second, plus the first times the derivative of the second. So that's negative 1/2 x squared plus y squared. Be careful with that because that's your chain rule. Minus 1. So if you're in debt $0.50 and you have to spend another $1, now you're in debt 3/2 of $1, right? $1.50. And then we have our derivative of the inside, which is going to be 2x. All right, so there's a lot going on there. Sorry about that. Our Fy is going to look the same thing. So we have 2's cancel. So we have y times x squared plus y squared to the negative 1/2 Fyy. And again, we have what's the derivative of the first times the second plus the first times the derivative. I'll do this one in 2 parts. I'm sorry for the last one. Second. All right. So here we have 1, it's this derivative. We have x squared plus y squared to the negative 1/2. Let's put some stuff together here, right? So we're going to have a minus. We have 1/2 times a 2, so that's going to go out. We have x times x, that's x squared. And then here we have x squared plus y squared to the negative 3/2. Okay, Fyy is going to look a lot similar to this. So it's going to be 1. Okay, then we're going to have x squared plus y squared to the negative 1/2. Okay, minus, well, now we're going to take this derivatives. We're going to do plus. Okay, y times, what are we doing? The negative 1/2 comes down in front, so it's negative 1/2 here. We have x squared plus y squared to the negative 3/2. Okay, times the chain rule, that's times 2y. Okay, that's where this came from. Okay, times the chain rule, 2y. So let's simplify this down. So we have x squared plus y squared to the negative 1/2. Okay, there's a negative sign here, right? There's this negative right here. So minus the 2's cancel. So we have a y squared, that's this one and this one. Okay, I'm kind of playing on some symmetry here, just kind of double checking my other answer. Okay, y times y, and then we have x squared plus y squared to the negative 3/2. Oh, that looks delightful, doesn't it? Okay, so there's our fxx and fyy. Okay, so what do we have next? Well, let's see here. Actually, this one's going to be anticlimactic as well. Okay, so let's see here. We have x, y. All right, what is this going to be? So we're going to take this function here, right? This is my fx. And we're going to take this derivative with respect to y, right? So let's not take the derivative just yet. Let's just hold off and write down, what is fx? All right, this was x times x squared plus y squared to the negative 1/2, right? So remember, we're going to take this derivative with respect to y now. This is all times, right? So it's like having a 3 times all of this. So that is going to stay the same, x. Then we have to take this derivative here. So this is going to be negative 1/2, it's a times, negative 1/2 x squared plus y squared, right? Take the derivative of the x to, or the negative 1/2 function, so that's negative 3/2. 1/2 comes down in front, times the chain. What's the chain? The chain is 2y. Okay, so what do we end up with? We end up with xy, because the 2's cancel, so we have negative xy times x squared plus y squared to the negative 3/2. All right, in algebra that would look like negative xy over x squared plus y squared to the 3/2 power. All right, that's what we're looking at. All right, now we have to solve fx equals 0. So fx is what? Fx is x over x squared plus y squared to the negative 1/2. Okay? Fy is equal to y over x squared plus y squared. Oops, I don't need to the negative 1/2. I just need to the 1/2. There we go. All right, so again, taking a look back all the way here, right? We have a y, we have over x squared plus y squared to the 1/2 power. Okay, what are we going to do with this? We're going to set these equal to 0. We're going to set these equal to 0. How do we solve rational functions? Well, the first thing we do is we multiply by the denominators to make sure that they're not rational functions. Okay, so we have fx is equal to x over x squared plus y squared to the 1/2 power equals 0. I'm going to multiply both sides by x squared plus y squared to the 1/2. X squared plus y squared to the 1/2. What are we left with? We're left with x equals 0. Same deal goes here, right? We're going to say x squared plus y squared to the 1/2 times y over x squared plus y squared to the 1/2 is equal to 0 times x squared plus y squared to the 1/2. Right? This is going to cancel. What are we going to be left with? Y equals, and then 0. Oh, well, that's convenient. Okay, I told you it was going to be anticlimactic. Okay, so there's our point. That's our critical point. There's our critical point. Let's see, what are we doing next? We are going to go ahead and we have to calculate our determinant. So we need f of xx times f of yy minus f of xy squared. Okay, and it's going to be really anticlimactic because after all this work, right, what are we doing? We're plugging in zeros everywhere. If I plug in zeros here, I plug in zeros there, 0. Plug in zeros here, plug in zeros there, 0. Plug in a 0 for all of these. Actually, we don't even get 0. We get undefined. Okay, this is a completely undefined quantity. So we have nothing. we have no solution, right? Maybe we have no conclusion. Okay, so this is a crummy example that I picked because it didn't work out so well. All right. So just to let you know that can happen. All right, that can happen. But there we are with it. Okay. So I just wanted to give you. Actually, I'm looking at the third example I found, and I don't like that one either. Let's try this one. Let's try an x cubed minus a 3xy plus a y cubed. Okay, and we'll see if that gives us something interesting. So what are we going to do here? we are going to find partial of x as 3x squared minus 3y, right? Partial of y, that's going to be negative 3x, right? Negative 3x plus partial of y, this is 3y squared. Don't know if we can do this one. I don't think we can. Well, that teaches me to come up with a thing. Because look, we're going to try to solve these together. We're going to say 3x squared minus 3y is equal to 0. Actually, maybe we could do. Maybe we can do. Equal 0. All right. So in order to solve this, right, we have 3x squared equals 3y. We have 3y squared equals 3x. So we have x squared equals y, or y squared equals x. Pick one. Okay, let's pick this one. All right, let's pick that one. So here's my x. Right, here's my x. So we have x squared is equal to y. We're going to put it back on the other side here. So we have y to the fourth minus y is equal to 0. Oh, I don't want to pick this one now. We have y cubed minus 1 is equal to 0. See that? We pull y out of both of these, and we have y equals 0 or y equals 1. Okay. So we're going to have y equals 0, or we have y cubed minus 1 equals 0. Easier said than done on this one. Okay. Sure, serves me right for coming up with my own problem here. All right. Why don't we do it this way? Okay, and then y would be 1. So we have y equals 0, y equals 1. So let's see here. We have x is equal to y squared, right? That's a solution we had. X was equal to y squared. So, or y squared is equal to x. So when y is equal to 0, 0 equals x. Okay, so that's a thing. So we have a point 0, 0. And when y squared equals x, we have, and y is 1, then we have y equals 1 equals x. Okay, 1 squared equals x. So the other point we have is 1, 1. All right, so we have 2 points to check. All right, I kind of jumped through it. I did step 3. We didn't do step 2 yet. All right, so let me go ahead and write down, what is my fx? All right, what is my fx? Fx was, it looks like 3x squared minus 3y. This is 3x squared minus 3y. Y, that was, what was this? This was negative 3x plus 3y squared. Okay. Let's take our second derivatives. So here is fxx. Take this derivative again with respect to x. Right, we get 2 times 3, we get 6x. Fyy, we get 0, we get 6y. Right? What about my f of xy? We're going to take this value, right, or this value. So we're going to say, what is this derivative with respect to x? Negative 3. Okay. So we have that sorted out. Now, what do we do with this? Well, we have 2 points to test. We have when x is 0 and y is 0. All right. So what is my fxx, fyy minus fxy squared? Right. That's going to be 6x, 6y minus negative 3 squared. Okay. So it's going to be 36xy minus 9. Okay, what do we do with the x and the y? Well, one time we have x equals 0 and y equals 0. That's one of the pairs of points that we found. If I plug that in, right, we get 0 minus 9. My determinant, right, is going to be less than 0. So we have a saddle point at, right, 0, 0. Okay, what about the other one? Well, we also have a point at x equals 1, y equals 1, right? So that's where we're going to have 6 times 1 times 6 times 1, right? X is 1, y is 1, minus 9. 36 minus 9 is a positive number, okay? So now we have to check, what is fxx at x equals 1, y equals 1, right? Because that's where we are under. So going back and looking at what is fxx? Fxx is 6x. When x is 1, this is a positive number. 6x, 6 times 1, this is a positive number. So we have the determinant, right, is greater than 0. 36 minus 9 is a bigger number than 0. And we have fxx. So we have this is bigger than 0, and fxx is greater than 0. Well, when that happens, we had a relative minimum. Okay? It's not an absolute min, it's a relative minimum. Okay? So you will find numbers that can be lower, but you know, this is our relative min. Okay? So we have two extrema points. We have the saddle point at 0, 0. We have a relative min at 1, 1. Okay. So that would be our solution for this. Can I draw it? Like, no, I can't draw it. I mean, I could give it a shot, but it would look terrible. So we're not going to draw it. Okay. There's 3D graphing software. Knock yourself out. But we're not gonna try to draw it. Okay. So that is our third one. So realize when you've got an x cubed or a y cubed in here, that's where it's going to get a little complicated, right? All right. So I'm going to leave you go with that. I just wanted to let you know what would happen. Like, you know, all the examples we did so far, we pretty much got like two systems of equations that were both linear, which is nice, and we usually got one solution, which is nice. But it doesn't have to be that way. And I just want to let you know, like, what do you do if it doesn't work out to be perfect? All right. So good luck with that, and do your homework, and we will meet tomorrow.